Right, first question. So use a result limit sine x over x is 1 when x is approaching 0. Okay, why this is true? Because when x is approaching 0, sine 0 is 0 over 0. So we can use the L'Hopital's rule. It is, you differentiate sine, it is cosine, right? And then you differentiate x, it is 1. So it's a limit cosine x over 1. And then cosine 0 is 1, so the result is 1. Okay, suppose you already know sine x over x, so limit is 1 when x is approaching 0. Then, for example, find out limit sine x squared over x squared. Okay, here you can use the substitution. You can see actually you can let t to be x squared. All right, then when x is approaching 0, t, which is x squared, it is also approaching 0. Right, when x is approaching 0, x squared is also approaching 0. Okay, which means t is approaching 0 as well. So you can rewrite this limit as a limit of t. So the limit of t is approaching 0 sine, it's no longer x squared, it's t here. Okay, over t. And then this is exactly 1. Okay, that's the first one. And the second one, limit sine 3x over x when x is approaching 0. So here you have a sine 3x, right? So you want to pair it with 3x. So you can put a 3 on the bottom. But if you put a 3 on the bottom, you have to put a 3 on the top as well to balance it. Okay? So now, again, you can use the substitution. You can let t to be 3x. Then when x is approaching 0, t is also approaching 0. Okay, so it's sine t over t. The 3, you can put it in the front. So it's a limit sine t over t when t is approaching 0, which is also 1. Okay, so it's 3 times 1. It's 3. So part C, it's a limit sine x squared over sine x when x is approaching 0. Okay, so for the top, sine x squared, you want to pair it with x squared, right? So you can put an x squared on the bottom, so it's sine x squared over x squared. But since you put it on the bottom, you also need to put it on the top as well to balance it, right? But here, because you have a sine x, so on the top you want an x, right? On the top you want an x times another x. So now you multiply both the top and the bottom with x squared, right? But if you write it this way, actually I have 3 parts of the limit. The first part of the limit, okay, from problem part A, you already know this limit is 1. Okay, and then the second part of the limit, you also know the limit is 1. Okay, then the third part of the limit, you know the limit is 0. Okay, so the result is just 1 times 1 times 0. Okay, the result is 0. Part D, limit x is approaching pi sine x minus pi over x minus pi. Okay, so again, you can let t to be x minus pi. So as x is approaching pi, your t is approaching 0. Okay, so this part is when x is approaching pi, it's exactly t is approaching 0, and sine x minus pi is t, x minus pi on the bottom is also t. Okay, so it's sine t over t when t is approaching 0, it's also 1. Okay, for part E, it's a limit x approaching 0 sine x over x. Okay, here, sine x, I want to pair it with sine x because inside the sine, I have a sine x, right? So I want to pair it with sine x. So it's a limit x approaching 0 sine x over sine x. Because I put a sine x on the bottom, so I need to put a sine x on the top. Okay, times sine x over x. And now for this first part, I can do a substitution, right? I can let t to be sine x. So now, when x is approaching 0, the t is sine x. Sine 0 is also 0, right? So it's same as t is approaching 0. So the top is sine t over the bottom, it's t. Okay, times the second part is just a limit, sine x over x. Okay, so when t is approaching 0, sine t over t, it is approaching 1, right? When x is approaching 0, sine x over x is also approaching 1. So the result is 1 times 1. Okay, part F. Limit x is approaching positive infinity, x times sine 1 over x. So now, you can rewrite it as sine 1 over x over 1 over x. Okay, because if you're writing this way, you can do the substitution. T is 1 over x. Then when x is approaching infinity, right? Yeah, when x is approaching infinity, or t is approaching 0 from the positive side. So the top is sine t, over the bottom it is t. Okay, sine t over t, as t is approaching 0, the result is 1. Okay, the result is 1.